So, we are going to discuss about the solution of Public Service Commission Sub Assistant Engineer 2018 complete solution from question number 1 to 100. The first question: one of the control springs of a permanent magnet moving coil ammeter is broken. If connected in a circuit, the meter would read option D. The meter would read an indefinite figure. Now, what is the reason why the meter would read an indefinite figure? The meter would read an indefinite figure because we know that for a definite reading, the controlling torque has to be equal to the deflecting torque. But if the controlling springs are broken, then the controlling torque cannot be produced. So, a steady definite figure is to read a steady definite figure will be impossible, and the pointer will rotate continuously. Thus, the meter would read an indefinite figure. Next question. In squirrel cage induction motor, the rotor slots are usually given slight skew. This is done to eliminate magnetic locking between stator and rotor and to reduce magnetic help. Third question. In case the air gap in an induction motor is increased, what will happen? Now, if the air gap of an induction motor is increased, then the reluctance will increase in the air gap region. Now, to overcome that reluctance, the machine will need more magnetizing current, and magnetizing current is inversely proportional to the power factor. So, more the magnetizing current, the less will be the power factor. Therefore, ultimately, the power factor will decrease. Fourth question. The mass of an ion liberated at an electrode is directly proportional to the quantity of electricity. So, this is Faraday's law of electrolysis. Now, question number 5. In a lead acid battery, the energy is stored in the form of chemical energy. Question number 6. When the pointer of an indicating instrument is in the final deflection position, at that time damping torque is 0. Option number C. Damping torque acts when the pointer is close to the reading in order to damp the vibration or oscillation, you must say, that the pointer does before being steady. So when it becomes steady, at that time deflecting torque is equal to the controlling torque and the damping torque is 0. Two holes in the disc of energy meter are drilled at opposite sides of the spindle. Why this is done? This is done to eliminate creeping at no load. Question number 8. The electrical power to a megger is provided by a permanent magnet DC generator. Question number 9. The disc of an instrument using eddy current damping should be option C, conducting and non-magnetic material. Now question number 10. In a three-phase power measurement by 2 wattmeter method, both the wattmeters had identical readings. The power factor of the load was. Now this question is interesting. This says that the 2 wattmeter readings are identical. Now this happens when the power factor is unity. Now the question may arise, what happens if the power factor is other than unity? That is, if the power factor is 0. Now if the power factor, now this the power factor is if the power factor is 0, then what will the wattmeters read? In that case, both the wattmeters will read identical values but opposite. That is, one will be positive and the other one will be negative. Now if the readings, the power factor is between 0 to 0.5, then in that case one of the wattmeter will read negative value and the other one will read positive value. If the power factor is 0.5, then the one of the wattmeter will read a positive value and the other one will read 0. If the power factor is between 0.5 to unity, then both the wattmeters will read positive value and one of the wattmeters value will be greater than the other. Now this is for these conditions are all for lagging power factor. That is, when the power factor is lagging. But what will happen if the power factor is leading? If the power factor is leading, then suppose in case of lagging, the wattmeter 1 will, if supposed that wattmeter 1 is reading a greater value than wattmeter 2, then in case of leading, the reading will interchanged. That is, wattmeter 2 now will read a greater value than wattmeter 1. So in zero power factor, when wattmeter 1 was reading positive and wattmeter 2 was reading negative and the readings were identical of same value, in case of lagging, now in case of leading, wattmeter 2 will read positive and wattmeter 1 will read negative and the readings will be of same value. In case of power factor between 0 to 0.5, where the wattmeter value was positive and wattmeter wattmeter 1 value was positive and wattmeter 2 value was negative. Now in case of leading, wattmeter 2 value will be positive and wattmeter 1 value will be negative. And for unity power for 0.5 power factor, where in case of lagging, wattmeter 1 was reading a positive value and wattmeter 2 was reading 0 value. Now in case of leading, wattmeter 2 will be reading a positive value and wattmeter 1 will be reading 0. And from power factor 0.5 to unity, where the readings of wattmeter 1 and wattmeter 2 were both positive, where wattmeter 1 reading was greater than wattmeter 2 in case of lagging. Now this will change. Wattmeter 2 will be having a greater value than wattmeter 1 in case of leading. And in case of unity power factor, the condition will be same, that is wattmeter 1 will be reading the same value as wattmeter 2 and both will be positive. For your simplicity, I can show you a chart. Here comes the chart. At 0 power factor, wattmeter 1 and wattmeter 2 value are same but opposite to one another. That is, wattmeter 1 is positive and wattmeter 2 is negative. This is for lagging power factor. But in case of leading power factor, W2 should be greater than W1. That is, in case of leading power factor, our W2 will be positive and W1 will be negative, but both will have the same value. At power factor 0 to 0.5, greater than 0 and less than 0.5, wattmeter 1 is positive and wattmeter 2 is negative and values are unequal. This is in case of lagging, but in case of leading, W2 will be positive and W1 will be negative and the values will be unequal. And at power factor 0.5, wattmeter 1 will be positive while wattmeter 2 is 0 in case of lagging, and in case of leading, wattmeter 2 will be positive and wattmeter 1 is 0. Now at power factor 0.5 and 0.5, at power factor above 0.5 and less than unity, wattmeter 1 will read positive and wattmeter 2 will also read positive, but the values are unequal and wattmeter 1 is greater than wattmeter 2. This is the case in case of lagging, but in case of leading, wattmeter 2 will have a greater value than wattmeter 1. At power factor unity, both the values of wattmeter 1 and wattmeter 2 will be same and both will be positive. This is same for leading power factor also. Now we are coming to the next question.